To solve these equations, we are going to use the zero property. And in using the zero property, I'm just going to color code this to help me talk about it a little bit easier. So I'm going to say this red one multiplied by the blue one. So I have these two binomials multiplied together. Well, if red multiplied by blue is equal to 0, the only way that can happen is if either the red or the blue equals 0. So we need to figure out what number makes the red one equal 0 and what number makes the blue one equal to 0. So that's why the next thing we're going to do is set each one of these, the red one equal to 0 and the blue one equal to 0, and solve. So if I solve these little mini equations, I would subtract 5 from both sides, and then I have 2u equals -5. Then I'm going to get rid of times 2 by dividing, and I end up with u is equal to -5/2. This one right here, I subtract 1 from both sides, and I find that u is equal to -1. But let's take a moment and think about what is it that we found? Like, why did this work? If I substitute -5/2 back into the red one, 2 multiplied by -5/2 is -5, and -5 plus 5 is 0. -5/2 substituted in here gives me 3.5, but 0 times 3.5 is 0. We found the number that made the red one equal 0. If I plug -1 back into the original, 2 times -1 plus 5 is 3, and 1 minus 1 is 0. 3 times 0 is 0. So we're finding the numbers that make these individual pieces equal 0 to solve the equation. So this next one here, I have 2v plus 5, so I'm going to make that one red, multiplied by 6 minus v, so I'm going to make that one blue. So if I have red times blue is equal to 0, then either the red one is 0 or the blue one is 0. So I'm going to set the red one equal to 0, and I'm going to set the blue one equal to 0, and solve. So solving, I'm going to subtract 5 from both sides, divide by 2, and I end up getting -5/2. I could subtract 6 and then divide by -1, but I think it would be faster just to add over v to get v by itself. So if I add v to both sides, I find out that v is 6. These are the answers to our equation. But one more time, the reason this is working is if I plug -5/2 back into the original, I get 0 times the number. And if I plug 6 back into the original, I'm going to end up with some number times 0. So we're finding the numbers that make the individual factors equal 0. Okay, the only difference here is we've got a little bit more going on. So I'm going to say I have -3z, I'm going to refer to that as red, multiplied by z plus 7, so that'll be blue, and then z plus 5, let's make that one maybe green. Okay, so if I have red times blue times green equals 0, then if any one of those red, blue, or green become the number 0, we'll get 0. So we want to find out what number makes each one of these equal 0. So we're going to set the red one equal to 0. I'm going to set the blue one equal to 0. And then lastly, I'm going to set the green one equal to 0. Solve each individual. And so this first one, the 3z equals 0, if I want to get rid of multiply by -3, I'm going to divide by -3. So dividing both sides by -3, 0 divided by anything is 0. Okay, to solve that one, subtract 7 from both sides, and I find -7. Subtract 5 from both sides, and I get -5. And what just happened is if I plug 0 back in here, negative 3 times 0 is 0. 0 plus 7 is 7. 0 plus 5 is 5. 0 times 7 times 5 equals 0. Or if I plug negative 7 up here, I end up getting 21 times 0 times negative 2, which is 0. And if I plug negative 5 back in here, I'll get 15 times 2 times 0. Okay, so this last one, I added this one in because the pieces that are being multiplied together, the first one doesn't have a variable. I have 2 multiplied by x plus 1 multiplied by x minus 3. If you just go with process, and sometimes we get caught up in that, we're like, okay, things are multiplied together equal to 0. Let's set each piece equal to 0. So I go to set each piece equal to 0, and I set 2 equal to 0. Well, I mean, that's nonsense, right? It's impossible for the number 2 to be 0. So this doesn't lead to any solutions. No matter what number I plug in for x, it's not going to change the fact that that's 2. So that's just nothing. Then I set the x plus 1 equal to 0 and solve. So if I subtract 1 from both sides, I find out that x could be negative 1. And then if I set the green one equal to 0 and add 3, I find out that x is equal to 3. So by plugging negative 1 back into the original, I would have 2 multiplied by 0 times negative 4, which is 0. If I plug 3 back into the original, I'd have 2 times 4 times 0. So your main idea is when you have something factored equal to 0, we're using the 0 property. When things multiply together to get 0, then one of those little pieces has to be 0. So we set each piece equal to 0 and solve, and those are the numbers that make those little individual pieces equal 0, and we have our answer.